indeed Hendrik with the TLSNotary team, which is a research project inside PSE, so the Privacy and Scaling Explorations Lab from the Ethereum Foundation. So I'm happy to share with you that almost the entire TLSNotary team is here. So if you have questions, come find us. Today you can find us at the booth, but our team will also be hacking in the other track. So if we're not at the booth, go find us somewhere where we're hacking, and then just discuss your questions or ideas with us. We're very happy to discuss them. So first, why are we putting so much effort into developing TLSNotary? Well, our motivation is that we want to liberate your private data. So today, lots of our data is stored on servers of centralized companies. And so TLSNotary found a way to unlock that data so you can make it portable and reuse it somewhere else. But so let's dive into it, what TLSNotary actually is. So I assume most of you know what TLS is. So it's the S is in HTTPS, so the transport layer security. TLS is a great way to guarantee that when Alice gets data from a server, that the data she gets actually comes from the server, and that also nobody on the network tampered with that data. And so there it serves its purpose very well. But where TLS doesn't help is when Alice wants to share that data with Bob. Because TLS uses symmetric encryption, Bob has no guarantees that Alice didn't tamper with the data. And so one example here could be you have a bank website, Alice wants to needs information from that bank to negotiate a deal with a mortgage lender, Bob. And so Alice can log into the website of the bank and get a view on her account. So she has actually $100,000 there. But then how does Bob know? So today lots of people just take a screenshot, but so there's lots of problems there. So Alice could doctor that screenshot, and there's often more information on that screenshot that needs to be shared. So the go-to status quo solution there is to use OAuth, but there's also issues there. So there's another trusted party. The bank server needs to cooperate and give that third party access. And then there's also only very coarse levels of configuration for your privacy. And so that's where TLSNotary steps in. So with TLSNotary, you do the TLS connection with multiple parties. And so it has the same guarantees as TLS itself. So you also get proof that the data is authentic, but it also allows you to take that for Bob to have guarantees about the authenticity. And so in a nutshell, that makes the data that was on the server portable. And at the same time, TLSNotary also does not depend on cooperation of the server. So at the server side, nothing needs to change. And also no extra parties are involved. And as I will explain next, it also helps you or gives full control to Alice for her privacy. Because once the TLS connection is set up and Alice wants to share data with Bob, she has the option to redact data. So to leave out data while Bob still has cryptographic guarantees that the data is authentic. And that can be further augmented with zero-knowledge proofs. So instead of sharing the actual address, you could add a proof that you're not in the US, for example, or instead of sharing the actual birth date, you add a proof that you're over 18. So how does it actually work? So before we go to TLSNotary. Let's have a look at standard TLS first. So from a high-level perspective, if you have very detailed questions, so the real experts are at the venue or also in the audience here. But so just to give you a rough idea how it works. So first, Alice and the server exchange their public keys. They negotiate on session keys with cryptography. And then once they each have the same key, so it's a symmetric key, they then can share or send encrypted messages over the network with some kind of checksum, so that you also know that nothing changed, and so that way they can very effectively communicate in a safe way. So with TLSNotary, the left part, the server is almost the same. And by the way, I will from now on I will use Prover instead of Alice because she has access to the data that she wants to share with Bob, and Bob will verify that data. So for this presentation, I will now use a prover and verifier for those roles. But so I was saying the server, so from the server's perspective, nothing changes. So it's still regular TLS protocol. But the client side of TLS is split in two roles. So you have a prover and a verifier that needs to cooperate to communicate with the TLS server. So instead of having just Alice's public key, it's now a combination of the keys of the prover and the verifier. And then instead of Alice doing all the communication, she needs to cooperate with secure multi-party computation with the verifier. And so that gives cryptographic guarantees that Alice, the prover, cannot cheat and cannot send messages without the cooperation of the verifier, and also that Alice or the prover cannot change the data afterwards. So they really have to jointly compute the keys. And then also something important that I didn't mention. So both the prover and verifier have private inputs. And so the verifier only sees encrypted data. So never the plain text until the very end of the process. And also the prover cannot forge the response because it first commits to the encrypted data before it can decrypt it. And so that whole system is sound and guarantees that nobody is cheating or nobody is tampering with the data. To make that a bit more practical and to show that TLSNotary actually works in practice, I've created a small setup where there's different roles. So the prover in this case has access to private data on the Star Wars API website. And so what the prover wants to prove to the verifier is that he has private information on Luke Skywalker. And so he will share that with the verifier, but he will redact the home world. And then the verifier will so cooperate in the multi-party TLS session, and then afterwards check that the data is authentic and correct. So I didn't want to tempt the demo gods, so I recorded the video. So on the left side you have the prover, and on the right side you have the verifier. So now I'm starting a verifier server, so which is listening, and so the prover runs in a browser, and so now the prover and the verifier are exchanging data to set up the circuits for the multi-party computation, and so yeah, that takes some communication. And so now they have set up the TLS keys. There's encryption and decryption going on. And we're already now in the finalization phase, and big success. So we have exchanged data, and so let me zoom in on the final. Oh. on the final result. So this is what the verifier gets in the end. So we got a response from the Swappy server. We have a secret HTML header here that's redacted. And also, as you can see here in the JSON data, the home world is redacted, but everything else, the verifier has cryptographic guarantees that nobody is cheating in this setup. So this was actually a very artificial example. So the data on the Swappy server wasn't even really private, but you can imagine for real use cases, what is private information that matters? It's identity information, reputation on websites like Airbnb if you want to reuse that somewhere else. Health information is an important one where everybody agrees that privacy is really important. You could also like prove that you own certain accounts. Also like real world assets. If you have a Tesla car, that also comes with a Tesla account. So you could prove stuff there that you actually own stuff. And so this unlocks a lot of use cases that were not possible before. So we're also very curious ourselves to see what you all will find for new use cases for TLS Notary. So for most use cases, the setup I've shown before with just a server, prover, verifier should be enough. But for certain use cases, you want the proofs to be reusable. And so for that scenario, it's also possible to split the MPC TLS verification from the actual data verification. And so that's what you see here in this diagram. So we introduced the notary here who only does the MPC TLS verification, and then the data itself is checked by somebody else. Of course, in this setup, it's important that the notary is trustworthy, because if the prover were to run his own notary, then we're back to square one, where you do use regular TLS, and then you could just fabricate any data that suits you. But so in this scenario, you can then reuse the proofs you have or the signed data with a second verifier. And so for some use cases, that's preferable. And so this way you really get portable data that you can take anywhere, with the only side note that the one verifying the data has to trust that the notary is that did not collude with the prover and is truly neutral. So that's the extra trust that's required. And so for on-chain applications, you're more towards this setting. So also for the notary server, I've prepared a small demo. So in this use case, the prover wants to prove to a verifier I have a Twitter account. So in this case, I'm the prover, and I will prove that I have a Twitter account or an X account nowadays. And then as the verifier, I will use a very simple online tool that we built that just visualizes the proof and does the checks. This is actually an example that we have on our quick start guide. So if you want to start exploring or playing around with TLS Notary, you can just follow that link or go to our docs first, and then you can run this example very easily yourself. So again, I have recorded it. So we are using a TLS Notary extension here, and what I'm doing is I open a debug view so that you can follow along with the nodes. So what the extension does, it monitors all requests, and so there's one specific request that we can use to get your username. And so in the extension, I'm clicking the notarize button. So it's now doing the whole MPC dance. I took a a quick redaction here to not leak any of my session keys. But so in the end, you get a proof, which is a JSON file with some redacted data, but I will download it now to my computer. It's still in development, so I'm adding the JSON extension here. And then when I have the JSON extension, I can go to this visualizer website we have. We're working on a better version also. And then you can see it's not valid because I'm using the wrong public key. But when I use the correct public key, you see that the verifier can now see that when the proof was made, the headers are redacted, and that the received data has my Twitter username there. So now I could also use this proof for different verifiers. So say that you need some kind of guarantee that I'm a real person. Maybe you want to combine a few different sources to just prove you're human or whatever, some kind of KYC. This could be used. Yeah. And then TLSNotary is open source. It's a public good. It's available under MIT or Apache 2, your choice. It's written in Rust, but it can be compiled to WebAssembly, so it can easily be used in TypeScript too. So that's why I had the demo in 2 sites, in the browser and in the terminal. So yeah, go to our website for documentation. As an extra incentive for you guys to choose TLSNotary to build on, we have a $2,000 bounty. If you use this QR code, you also get to a special page on our Notion website with extra links to get you started as quickly as possible. So yeah, in a nutshell, this was TLSNotary. We also have a booth, but if you have questions now, shoot.
Thank you very much. Does anybody have any questions? Yes.
Hi, thanks for the presentation. Does this require any changes from how CAs operate, the types of certificates used today?
No, so that all stays the same, but as a verifier, you have the option on how you get the certificates. So, so that it's also lots of building blocks, so you choose how you combine them. But so that's all in your control.
So it's basically backwards compatible with how browsers work today, how CAs work today.
Yeah, yeah,
okay.
yeah.
A bit of a follow-up question. Given that dependence, or I guess like how it's built on the existing CA system today, how does this work with something like websites that are ENS or like don't actually use the regular DNS system? So say I wanted to publish my website with a pure IPFS front end that doesn't use the DNS existing, like intersection of SSL, DNS, and HTTP today.
Well, so if you know what you're doing and you know where to get it, you can get it where you know it is. So it's flexible. Yeah.
So I guess I wouldn't. So I could just use the building blocks and generate my own certs and use that.
Well, it's the verifier that has to trust the certificates. Yeah. So if you generate them yourself, and then there is no trust. Yeah.
Sorry, I don't want to steal if anybody else has more questions. But, so are you working on any standards tracks for this? Are you working in the IETF or W3C?
No. So this is what we actually want, what our end game is, that everybody would simply sign their data. So if the data would be signed at the source, then this whole dance wouldn't be necessary. But so lots of data servers don't have the incentive to sign it because they would just be taking more responsibility. So this is also some kind of activism tool to educate the world and to help people demand signed data. So in the perfect world, TLS Notary would not be necessary.
Right. I guess like a final question, have you thought about what native browser integration of something like this would look like? Because it does seem to need to escape the, I guess, like origin isolation and things like that. You need to make a, I guess, a CORS request out to the notary, for example, and it seems to chain a few different types of HTTP request response.
Yeah. Yeah, it's steps. So we're now building in what's possible today. So in the browser, you need a WebSocket because you cannot set up the TCP connection in the browser. So there's some hoops we have to jump through. But yeah, it would be nice if browsers would support this. So it's a work in progress there.
Thank you very much. That's all we've got time for. If anyone has any more questions, PSC have a booth downstairs. Please go and speak to them, interact with our partners as much as possible.
Thank you.